ready, maybe. Okay, good evening, everyone. I'm Tom McQuillan. I'm LabVIEW champion, CLA, CLED, CTA. Some of you may know me from my LabVIEW YouTube channel, Tom's LabVIEW Adventure. If you're interested in object-oriented programming, Active Framework, DQMH, you'll see some of my resources on that YouTube channel. If you're not interested in object-oriented programming, you're going to hate this presentation. So you can come back in about an hour for the next one. Okay, I'm going to be talking about thinking inside the box. I didn't come up with this title. One of my new colleagues at JKI came up with it, and yeah, I quite liked it. Okay, in true LabVIEW fashion, I'm going to introduce our giant star female. This was one of my mentors when I was at university, Dr. Violetta Holmes. She was one of the people who got me into LabVIEW. She was one of the first to teach me like the LabVIEW fundamentals course when I was at uni. And I found out recently she passed away. And so, yeah, I suppose this one's her. She's one of the main reasons why I do LabVIEW now. So, in this presentation, I'm going to be going through thinking inside the box, because when I'm reviewing existing code bases, I see people are using and abusing object-oriented programming in LabVIEW. And that's mainly because there's not enough training in object-oriented programming. There's the NI course, which teaches you that, a class is a noun, methods are verbs, dogs go woof, but there's nothing really showing you how to develop an application. So in this presentation, I'm going to be taking you through perhaps 5 object-oriented design patterns that you can use in your projects. Also, you may have noticed there's a load of NI swag. There's some NI water bottles, there's some NI socks, there's some sunglasses, which have no protection whatsoever. Just be warned. There's a hoodie, there's a couple of t-shirts. If you want any of that, you're going to have to answer some of my questions. I don't know what they're going to be yet, so stay tuned. But yeah, I don't want to take it home with me. I've had it in my cupboard for 2.5 years. So it's staying here regardless. Okay. One of the biggest inspirations for this talk was people using and abusing objects. And the number one way that I see new people use object-oriented programming is by overusing inheritance. They think, I have an object, but I want it to do something new. I want to add functionality. I want to change functionality. So what they do, they create a child class and do everything in that child class. They want to change functionality again, so they create another child. But by overusing inheritance, we are reducing encapsulation, which is one of the pillars of object-oriented programming. So, inheritance is one pillar, encapsulation is another pillar. There are 2 more pillars. Can someone tell me what those pillars are?
Abstraction?
Possibly, I say abstraction comes under inheritance. Any other thoughts?
Reusability?
Almost. You're working your way up to a pair of sunglasses.
With no protection.
There's no protection.
Can you word the question again? What was the question?
So the 4 pillars of object-oriented programming, I guess 4 key principles. Okay. Oh, right. The thing is, when I show you, you'll be like, oh yeah, well, I knew that. We're going to be talking about encapsulation, inheritance, polymorphism, even composition. So, actually, by show of hands, who here uses object-oriented programming? Okay, 2/3, maybe 3/4. Who here feels like they're an expert in object-oriented programming? Okay, half. Alright. I was expecting a couple of hands there. So hopefully in this presentation I'll go through some things you perhaps didn't think about previously. If there's nothing for you in this presentation, feel free to heckle, put me to the test, see if you can catch me out. Right, so quick overview of object-oriented programming for those who don't do it. First concept, encapsulation. This is a class. That class has two things. It has data, so we could say a class is a data type, but it's a special data type. It has the ability to interact with data and perform functions. It does methods. Only these methods can interact with this data. So external sources, other bits of your application can't. Let's say you had a file I/O, a write-to-file function. There's no reason why your camera driver has to directly interface with a text file reference. So we're using encapsulation to lock down that ability. Inheritance. This is everyone's favourite. We have abstract class. In there we can have concrete implementations. Those concrete implementations can append brand new data and also brand new functions. But the power comes they also have the ability to use all of the parent functions. So we talk about parent classes or abstract classes, then child or concrete implementation classes. Oh. Where did that come from? Right, who can tell me what this is? Interface. Right. What's an interface?
It's a contract that describes, yeah.
I like that. So an interface is a contract. It defines behaviors. This particular interface could be a user interface. It has the behaviors of open panel, close panel, maximize. It could be minimize as well. But anything that implements an interface must be able to do it. I like the word contract that Baz used. A contract has been made here that has to be able to do it. All right, moving on to polymorphism. Polymorphism, this is the thing that everyone likes, also called dynamic dispatch. With dynamic dispatch, we can physically change the behavior that happens at runtime. We might have 3 different classes here, and these represent 3 different pieces of hardware. The way that we connect those 3 different pieces of hardware could be different. So if we wire in this class, that's going to have a different behavior to wiring in this bottom class with maybe a .NET reference. But I think the thing that gets overlooked most with dynamic dispatch and polymorphism in LabVIEW is it's not just about the functionality. The data type is changing. This, wiring back, is the equivalent of wiring a Boolean. This could be the same as wiring a cluster with a string, a reference, and a Boolean. That, well, that's a .NET reference. If we think back to polymorphism that we used to have before VIMs, VIMs, those would change the connector pane. We're doing a similar thing here. The way we connect to a .NET thing is going to be different to how we connect to a camera with an iMac string. What's next? Composition. Classes are data types, and you can put data types within classes. So this stands to reason. We have a camera here, and that camera has different ways of capturing images. And so we could call that like the acquisition strategy. We could go a bit further and say the acquisition strategy has an inheritance structure behind it. So we could have a strategy of collecting every image, the latest image, or just a snap, one single image. Okay. Right, now we're all experts in object-oriented programming. Let's move on to what I actually want to talk about, which are design patterns. In the previous slide, I talked about separating your camera with the strategy of collecting images. We're going to call that the strategy pattern. Who here has heard of the strategy pattern? Okay, a couple of us. Those of you who use composition a lot in your object-oriented code probably do this, but just haven't necessarily linked it with what it's called. So strategy, a behavioral design pattern to define algorithms and use them interchangeably. And so here we have our camera class. The camera needs to be able to acquire images, but there are different ways you can acquire images. You could get every image, get the latest image, get a single image. There are probably more different ways, different algorithms, but these are the three I've gone with. You know, I went with these three because I started a new project recently at JPI, but because I'm in the UK and the customer doesn't wake up until 4 o'clock in the evening, I implemented this design pattern so I could make a best guess of what the customer wants. But if it's different to this, well, that's fine. I can just swap it out. I can still develop 90% of my code and just change out one of these classes. Let's actually see that in action. Any questions? All right, let's wake up this one. Virtual machine. Let's see if I have a camera connected. Yes. All right. So this was a test bench for one of my recent customers, just to make sure I could interact with their camera. Okay. And so you get a list of cameras here. I can open a session. And then, assuming that initializes, I can start acquisition. And so, perfect. You can see me, and this is me getting the latest image. And so if there's any lag in the system, like this camera will go about 30 frames per second. But if there's any lag and my computer can't keep up, it will just show the latest and I'll miss all the ones before. But perhaps the customer doesn't want that functionality. Perhaps they just want a single snap. Well, I can just choose a different strategy and start acquisition, and there we go. It's updated, and there are functions in this particular strategy which tells the software, am I collecting one image, n images, or indefinite images? And I won't show you the code because it's for a customer project. I will show you just a couple of screenshots. Because the way I initialize the camera for the different strategies is if I get every image, I have to create a bit of a buffer that it can roll through. There's some more advanced IMAP functions I need to use. But if I just want a single image, well, the only thing I actually need to do is create an image reference and pass that through. So you can see that the functionality is wildly different, but I can swap between that functionality very straightforwardly. So that was initialization. This bit of code is just getting those images. Here I'm reading from the camera buffer. Here I'm just doing a snap to get, well, a single image from the camera. And for this particular project, I wanted the API to be as streamlined as possible. I wanted as few functions. I didn't want, I could have tried to be clever and made everything as dynamic as possible, but for this application, it didn't warrant it. Here, I'm specifying my camera. It's an iMac DX camera, like a Basler camera. I can connect to it, do some sort of initialization. Even here, I'm choosing whether I'm going to get a single frame, get every frame. I'm basically choosing between my strategies and reinitializing the camera for that particular strategy in then getting my image. Remember I said how polymorphism or dynamic dispatch is also changing the data type? Well, that's what I'm doing here. This function is just called getImage. But as you might know, when you use the vision development module from NI, your end customer has to pay about 400 or 500 euros per deployment. And so the customer might not want to have this forever. So instead, I've encapsulated every mention of essentially IMAC, apart from the image, apart from like the user interface, which actually you don't need to pay the license for, but everything else is encapsulated. So in the future, I could change the data that's coming out of here to be a 3D array for RGB values. I could be doing this via .NET and just have a .NET encapsulated class. Oh yeah, and then inside this function, I'm either putting in this strategy, the single image strategy, or the latest image strategy. I could have another wrapper as well to be every image strategy. And you know, this is just an encapsulation. These strategies could be loaded from disk. But again, I wanted this API to be as straightforward as possible. Hence why I've gone just for a case structure instead of trying to do more and more dynamic dispatch. Right, who has any questions, comments, or thoughts about any of this? Good? Yeah?
Are you using a specific tool to develop your code?
In this instance, no. But historically, yes, I've used the Goop toolkit.
Yeah.
Again, lots of nods from the audience. The Goop toolkit's good. I know VI Tech use GDS. So yeah, there are lots of tools out there. I haven't since working at JKI because they have their own internal frameworks. So yeah, there are tools available. Earlier I mentioned how it costs a lot of money per deployment every time you deploy the vision development module to a customer PC. And the way that NI license that is obviously going to be with some sort of licensing module, and the way you can implement licensing could be by using a proxy. So the next design pattern I'm going to talk about is the proxy design pattern, a structural design pattern to control access to an object. There are a couple of different reasons why you would want to control access. Licensing is one. If you have a license, you can have access to the object. If you don't have a license, well, you can't. Can anyone think of any other reasons why you might control access to an object?
Access.
Pardon?
Local access, internet access.
Internet access, for sure. There's a couple of different reasons. So proxy controls access. One could be restricting access or licensing. And I would also put if internet access is required but it's not present, then you could restrict access. Another is a virtual proxy. Let's think of creating a cache in memory. If you have a really heavy load, a function that takes maybe a minute to execute, you might just want to execute it once and keep the result in memory. And then the next time that function is called, just take it from the cache and display it to the user straight away. Another use case, does anyone use Active Framework? A couple. Within Active Framework, you may have come across a toolkit about remote endpoints. So how you can have your actor-based system communicating over a network or over to a CRIO, perhaps. That's done using a proxy. If you send an actor a message, if you implement a remote proxy, another actor might receive that message and secretly wrap it up. It controls access, puts it through a TCP pipeline onto the other side, onto your remote CRIO. Then the same proxy can unwrap it and your remote actor framework system can receive the message. But in the background, this is all it is. This class is controlling access to this class, and it can be as straightforward as a case structure. So, is the Vision Development module licensed? Yes. Well, that's great. You have access. Else, you don't. This is how it's set up. You're going to have some sort of interface, some sort of thing that defines, what the proxy needs to do. You have a real subject. Think of this as the Vision Development module. And this class is controlling access to the Vision Development module. You can see this arrow type here, which means in this class private data, there's actually this object, which means this has the power to either use the object or not use the object. And I'm using an interface here to define behaviors because this is a licensing module. However, it needs the behaviors of a vision system. And so we can use class inheritance to define what something is, and we can use interfaces to define behaviors. Okay, let's show this in action once again, actually. Shout out if you have any questions. You get a sneak peek of what we're doing next. We're doing proxy now. Okay, this is a caching example of proxy. So if we run this is going to send simple command line arguments to this virtual machine. When I press these buttons, it will send a who am I command to the system exec, and it will return some data, IP config, and system information. If I click who am I, it comes back with the virtual machine name, IP config, that takes a bit longer. Cool, system information, that takes a bit longer. Still, but there you go, it got there. But the thing is, this data isn't going to change, so why make the customer wait for that change? So instead, I'm going to enable this proxy. I'm going to enable caching. So now my proxy is enabled. The first time I run this is going to take exactly the same amount of time. But the second time I run this, all being well, notice how I'm now just drawing data directly from that object cache. Because this proxy is controlling access to the functions, to the object that takes a long time to run. And if I clear that cache just by reinitializing that proxy, I need to build up the cache once again. But now I've made that cache, I can click on this and it just displays the same data. Okay. Let's stop that, look at the block diagram. Okay, here I have a proxy class, and I can choose between the real class, which is using system exec directly, or a proxy. if I click on one of these functions, so whenever I click system information, this method is executing. And with dynamic dispatch, this screen will appear, and this is the real object. This is talking directly to system exec. So inside this VI, I'm just using the system exec function, and I'm passing in the command system info, and it outputs a response. I'm putting in a bit more of a weight here just to prove the point. However, if I use the proxy implementation, you can see what. Actually, I'll open up this VI because there's a bit to chat about. With this VI, what I'm doing is looking at the class private data at system information, and I'm seeing, is that string null? If it's null, then I need to actually talk to my system exec. If it's not null, then I can pass the string straight out. Just as a side note, in LabVIEW we don't have a concept of data being null. It can be an empty string, but an empty string is not a null string. So the way I implement nulls in LabVIEW is null is equal to this GUID, and I mean, I'm willing to take that on as a bug if by some chance my system exec is equal to that number. And like in here, it's just a constant. So
Why can't you use the end string?
Because system exec might just return an empty string. Like that's plausible for, I don't know.
Yeah, that's how it
Yeah.
work with long enough.
Cool. Any questions about Proxy?
Well, when the data you try to retrieve changes, and the proxy is responsible for updating it on some platform.
That's a great question. So the question was, but isn't this data going to change? Perhaps not with this particular system information, but if I'm displaying data to a user that's constantly changing, it is going to change it. So perhaps every 5 seconds you clear the proxy. So just reinitialize this proxy with those null values every time you receive a particular event that says system updated, or after a timeout. But yeah, for sure you need to clear it at some point.
But is it a responsibility of the proxy class?
Oh, is it a responsibility? Yes, I would say so. But this particular proxy is an implementation of what a proxy is. If you have lots of proxies, all of which need to clear data periodically, you could put that implementation in a parent proxy. And so that parent has the ability to reinitialize itself. In object-oriented programming, we have this thing called a stacked functionality, where a child implementation has access to its parent's implementation, and that has access to its parent's implementation. Used all the time in Active Framework, less so in other places. Right. Is there a problem? I have no concept of.
It's now, so you're around 40 minutes in. No, we have the open. It's now 24 seconds. So yeah. Take all the time.
Don't say that. Right, so page one. Well, this presentation, by the way, I've just taken design patterns out of this book. There's no original thought in here apart from the LabVIEW implementation from what's in here. This is the Gang of 4 book. There's about 20 or 27 of these design patterns. I've picked my 5-ish favourites, or the 5 I use most often. Why is this here? I used to work for Scientifica, who develop microscopes. So this was my lab back at Scientifica, and there's a microscope here, there's a laser, there's some optical stuff, even a sample there. However, this is what my lab looked like to me. All of these individual things, I was like, well, they're clearly all objects, but how do I organise all of those objects in my code? I had a project where, I wanted to be able to pick like maybe this reflector here and calculate the validity of the waveform from the microscope that was going through all of these other objects. But what's the quality like at this object? Or what's the quality like here or at my sample plate? Well, to solve that challenge, I used the composite design pattern. The composite design pattern is a structural design pattern. It allows you to treat a group of objects as a single object. So compose objects into subsystems and work on them as if they were individual objects. So think of a tree, for example. This object right at the bottom is made up of all of those other objects. This object is made up of those two objects. Or, depending on your application, you could think about it the other way around. You could say that this object is made up of this object, and this object, but none of those. Another non-LabVIEW analogy is, I forgot about this. So we can have this object is made up of all of those objects in the tree. This object here is just made up of those objects. So another one, and this object is just made up of itself. Like just another example, the customer orders one thing, that particular order though is made up of a box, it has 3 sub-modules, inside this sub-module is a hammer, this box is made up of 2 other boxes, there's a phone, headphones, a charger. We could go even deeper. These headphones are made up of composite materials, there's probably a circuit board, on that circuit board there are different discrete components, etc. Going back to my former job, this sample is receiving light that has come from or gone through all of these different objects. And like the scientist, the person doing these experiments could add in more mirrors, could add in things that split the beam or join the beam, things that change the wavelengths, things that cross over the wavelengths. So with all of that flexibility, how do I calculate what the sample is actually getting? Well, it's the composite pattern. That composite pattern, I could effectively say I have a laser here, and that laser could be branched into maybe 2 separate wavelengths, or it could be a dual wavelength laser. I have an optic here which splits that wavelength, maybe 60% of power goes here, maybe 40% goes down here, and this one, it joins 2 wavelengths until I get to my microscope paths. In my application, I actually flipped the tree the other way around. So I wanted to go from my sample and work out the validity of the data going backwards. So I say that this object has this object has that one, and that one. And a particular object, like this one, could have could be composed of multiple subsystems. And so we can do something like this. I've just put in 2 different classes here. And these 2 different classes can represent different things you might see on that laser optic table. This class could be a mirror, I could have another class that would split the beam, etc. But with like simple add functions, I could have an object coming in here, and I could add another object to that object. And then here, I get this object, which is already composed of this object. I can add another one, and this one is composed of those. Whenever I'm talking about object, I'm talking about a class on the block diagram. More specifically, I'm talking about a class wire on the block diagram. Here, you can see I have like 2 object constants, but actually I have 1, 2, 3, 4, 5, 6, 7, 8 objects. And those 8 objects I'm manipulating until I have a single object out, and this object, if I went backwards, I would find all of those 8 other objects.
You mean with objects, you mean also instances?
Yeah.
Oh.
An object is an instance of a class. Adding those objects, quite straightforward. This add function, I could just add this object to an array of objects. I could do the same for removing an object, just delete from array that comes out. Yeah, but the type of object here, that's where it gets kind of interesting. Well, if you like that sort of stuff. Let's close that one, close that one, close that, save that for later, save that for later, save that for later. Close. Composite. Perfect. This is a composite pattern. It's exactly the same code as before, but you can see it has a broken run array. That's because I've not completed the functionality. So Control-Shift-E, open up the project. The functionality I've not completed is, well, what actually goes in this private data, the array of nested objects. Ideally, I would have an array of myself, or rather, it would have an array of itself. But I don't get an OK, the equivalent of an OK run array. Gives me errors. What can I put here instead of
G-object?
G-object? Sounds good? So object control P. B. So control space control P, just swap it out for LabVIEW G-object. Now, if you go through this book onto the composition page, it will tell you to use the parent class of Composite. However, I don't like doing that because I think it just makes, there's an extra layer you don't really need. Instead, I just put G-object in here. So theoretically, any object could go inside of here, but that's not true because in this add function, you know, the connector pane is still the composite object. So if you wire anything that's not of this type, you'll get a broken wire. I was going to talk about something else here, but what about get? Oh yeah. Now, if I wanted to get that data, I don't want to get this. I don't want to get G-object. That's not very helpful to us. So instead, I can just put in a for loop here and then cast it to be the object type I want. So to specific class. Now this function is not changing the type of object in G. It's just changing how LabVIEW treats that wire. And I think that's an important distinction to make, because if this wire has lots of data, if then you cast it to the LabVIEW object that has no data, if then you cast it back down, you still keep all of that data because the object isn't changing. The rules of what you can do with that object is changing. Does that differentiation make sense? Yeah. Cool. And so now, I have a good run arrow. However, I'm not going to show you the good bit yet until I've gone through some slides. Let's talk about recursion. Because if I have an object that's made up of another object, which is made up of 5 different objects, and those 5 different objects are made up of 100 different objects each, I need some way of iterating through all of my objects to actually get those fundamental objects at the end, which represent the things on my light table, on my laser table. So a simple recursion exercise that I think everyone does is to list all of the files in a directory. So we use get folder info, and that outputs all of the files in that directory. Down here we get all of the folders in that directory. If we need to check all of the files and folders in this directory, so what we do, we click and drag, and now this VI has an instance of itself on the block diagram. And to do this, you just need to change the execution mode to the middle one.
Shared clones.
Shared clones.
Nice one.
Shared clones. However, can someone tell me how many instances of this VI will exist in memory when this VI is running? I mean, I don't know. It's going to be, yeah, it's not restricted. Or rather, it is restricted, it's just not in the way you want. So this is what I used to do, and I sort of fell into the trap of this recursing forever and ever, and it takes up too much memory. So instead, I use something called stacked recursion, which looks like this. What stacked recursion is a way of having a stack up here, and you add things to the stack and you remove things from the stack. My stack starts off with my directory path. I then delete from the stack. I remove something from the stack. I look in the folder, get all the folders and files. All of the folders go into the stack. And then I do the same thing again. I delete the bottom entry. And I go over and over again. Now, how many instances of this VI exist when it's running? 1, yeah. So that's stacked recursion. And the same is true for listing objects. Here, I could use my get function and then use another get function within itself, and do that over and over again. Or I can use stacked recursion, so I have my stack here, I delete from the stack, I get nested or composed objects, add it to the stack, and then I get my composite classes out. So I look up here, I put some diagram disable structures on here. Can't remember. Control space, Control Shift R should remove this. Yeah.
And Control R, just maybe removes it all.
Yeah. Control R would just delete it, remove it. Well, we'll remove and rewire. Whereas Control Shift R will just remove the structure on the outside. Yeah, so here I have essentially 3 different types of recursion. This is, there you go, this is your bog standard recursion with the middle execution. Down here I have stacked recursion, which just returns an array of objects. Then down here, I'm doing stacked recursion, but I'm also looking at every object and doing a thing. This could be looking at, this is just adding a random number every time, but that could be doing anything. Now, getting all of those composed objects takes time, like regardless of the recursion technique you use. So, the question here is, what could we do instead of recreating this array every time? Huh? That's the last design pattern. Proxy. Okay, there's some murmurs of proxy. Yes, that is the right answer. We could just create a proxy here. So we could have a proxy class that, if this array is actually a null array, we recurse through all of those objects. Else, if it is a valid array, we just pass out that array we've already calculated. So we could use the proxy pattern alongside a composite pattern, so we don't need to do all of this recursion. We just do it once at the start, or whenever the user updates the system. We do it again. I just added another thing up here, like we could have a laser that splits the beam, even though we could have other systems that join the laser beam. You could have a tree that has a diamond shape. Cool. Any questions, comments, or thoughts?
So with the proxy, if one of the attributes of the objects in the array changes, how do you?
It's like before. You can either periodically just clear the proxy and recalculate, or like whenever the user clicks add function, like add something to the table, you could just remake that proxy cache in the background. So it's there ready for when the user wants to use the main result. Cool. Who likes Active Framework? Good. How does messaging work in Active Framework? Good. You'll have that swag in no time. Right. The commands pattern. I did have like a really neat transition between that and this. I forgot it. So command pattern, a behavioural design pattern to execute, schedule, ignore requests that are undoable. The Active Framework isn't implementing this properly, and I'll show you why. So the commands pattern, you're essentially having an object-based queue. So instead of having a variant enum queue in your QMH, you have an object, and that object is of type message interface. And implementing this interface, or inheriting from a message class, you could have X number of messages. And those particular messages could have their own hierarchy. Now, these classes, these message classes, have all of the data they need to execute the functionality. They have the methods they need to execute the functionality. So actually, the application, notice how I've used a different type of arrow here. The application doesn't necessarily know what it's going to execute. These classes are self-contained. They have all of the things they need to run. And this application just needs to facilitate that interface. Oh, there's a demo. let's command with undo. Okay, here is the command pattern. Process 1 is sending process 2 messages. I'm using Jeff wires or streams. Sorry, I literally just said they're using Jeff wires or streams, and then I looked back like, where are my queue functions? This is the enqueue function. I'm enqueuing an object here, and it's getting sent along asynchronously to here, where we have the execute. So every time I have a color value change, or I do command 2, command 3, or load a command from file, I'm sending this message to process 2. Process 2 then executes a message. Let's have a look inside. So when I... Is that not a splitter? So when I execute one of these messages, this message is going to change the color of the background. But notice how I'm keeping a track of what the previous color was. So inside this message object, I'm storing what the color used to be, and I am also changing the pane color in that sub-VI. This one is a method to maximize the screen. So here, again, I'm making a note of how big the screen used to be, whether it was minimize, maximize, standard. And then I'm maximizing it. And then lastly, I'm doing a wobble. And this wobble is literally just moving the front panel, swapping it. The opposite of a wobble is just a wobble, so I didn't implement a reverse wobble. But let's see it in action. Control E, Control R. Okay, let's choose a different background color. Let's choose red. I change the color. I maximize, I wobble, I change the background color again. Every time I create one of these events, I'm sending this object to my second loop, it's being executed. Also, make note that I'm creating an array of all these messages. That's because when I then close this panel, this executes at the very end, and it's an undo ability. So I can now unexecute that code. So I close that, it changes its pane color, it should wobble, it should change its pane color again. There you go. The command pattern, actually, if you follow the rules, it says this interface, this command interface, must be able to execute and unexecute. So if you ever want to implement undo, redo in your applications, this is the best way of doing it. Instead of storing the current state of your application, which could be massive, you don't need to store configuration data that hasn't changed. Just store the data that has changed in an object. You could have this as some sort of ring buffer, so you only keep the last 10 undo redos. And then your customer can do Control Z, Control Y, or Control Shift Z for LabVIEW. Any questions about this?
So I don't have a question, I have a comment though.
Yep.
I personally feel there's nothing wrong with the command pattern, but in general, looking at the process 2, right? As a developer, I come back 4 months later. What does that loop do? Without clicking, tell me what kind of things it can do. Without looking at the LabVIEW project, right? You've got to go in, you've got to open them in LabVIEW, you look at the window, see what dynamic dispatch VIs there are, click on them. I can't easily just scroll through things. It's a pain, and that's one of my biggest gripes about Active Framework is.
With Active Framework, it is like Project Explorer programming. The framework itself, the G you see on screen doesn't often change. It's just about the class implementations, which is where tools come in, like the GDS tool, and having your UML diagrams come in handy.
There is a new tool that shows you the messaging structure in Actor Framework. It's called Bowser the Browser. And it's released by Zaya solution. So that gives you a better overview of your message.
It just seems like another barrier. Like if I just want to quickly see what does system do, like is the problem in this
Also,
process? I can't tell.
The thing is, when we use DQMH or QMH or a lot of these frameworks, your framework is inherently monolithic. You're not going to reuse that module in another application. With the command pattern, you're abstracting the module with what the module does. And actually, if you have a customer who, heaven forbid, changes their requirements or wants you to add new requirements, you can create a separate message that the application knows nothing about, and then make that application do it. It's up to you. Right. Ooh, okay, close that. This is another implementation of the command pattern. We have some message objects here. Those are going to be enqueued using a queue, which is nice, to this, which is dequeuing. It does the function. But down here, we're also enqueuing something else. This is just another function it's enqueuing from a remote process. And I'm aware I'm over time, but I'll get back soon.
Yeah, so about the time, we have the rule until 9 o'clock. I think everybody agrees that this is an amazing presentation, so I want to see it until the end. So if you need to leave, because people have private lives, it's okay. So maybe that sounds a little strange. During other meetings, if people have private lives, you need to go. If you go, please go in quiet fashion. But we have until 9 o'clock, so after this one, Paul is also.
We do have another presentation.
Yeah, we do have another presentation.
What do you mean? I have another 2 hours. So, right, message D is being enqueued. That's in a loop down here. D gets enqueued. If I send a message, I send A, then B, then C. There's a bit of a wait between sending A, B, and C. So actually, this rogue D message gets intercepted. You know, I used to teach the Advanced Architectures course for NI, and actually one of the things they taught was when you want to essentially implement a, what's it called? Begins with an M, a macro. When you want to implement a macro that does multiple functions one after the other, you should encapsulate it like this, and then send them all at the same time, or as close to the same time as possible. But as close to the same time as possible doesn't exist. Like, I'm like putting in a 1 second delay here just to make the point. Maybe 99.9% of the time it will work, and these 3 messages be enqueued and dequeued right next to each other. But you only need one bug to ruin everything. And if you're doing something like this where you need those 3 to execute at the same time or directly after each other, it's probably the type of application where you can't afford to have these intercepts. So instead, we're going to go back to the composite pattern. Now with the composite pattern, remember that this object is made up of other objects. It's made up of an array of other objects. Which means I'm just enqueuing one object. And using the command pattern, this object gets dequeued down here. And if I look at the composite class .do, you know, that array of objects comes out here, and I can perform that functionality. and there's no way that something can intercept a single element in that queue once it's been sent. Yeah.
That's also how the batch messages in Active Framework function.
Yeah, this there's a batch message in AF. So if we send Composite, we can see that like it does this all as one element. It's just element 146. Whereas ABC, you get A, D, D, B, D, C. Questions, comments, or thoughts about this? Cool.
I didn't know I needed it.
Right, there's one more design pattern I'm going to go through, and this next design pattern is arguably the most complicated one you'll see in this book. But all it is like the strategy pattern, but on drugs. It's called the visitor pattern. It's a behavioral design pattern that allows you to separate algorithms from the objects on which they operate. So, imagine you have a customer that doesn't give you all of the requirements at the start of the project. Just imagine in some dystopian world, you've got that sort of customer. And so you need a way of adding those requirements. Or what's more likely is your project evolves over time. So phase 1 of your project gets complete, and then the requirements for phase 2 and phase 3 might happen in 5 years' time or 10 years' time, and you need to future-proof your code. The visitor pattern is a great way of getting a hook into your classes that allow you to essentially inject functionality. Remember the strategy pattern where we had the camera, and that camera could use different strategies? Imagine that, but it's happening on both sides. Imagine we have an element here. Think of a test stand. Think of this as a test stand step, and these are different types of test stand steps. So this could be an action step, this could be a subsequence, we could have a pass-fail step. Does anyone use test stands? Does this make sense? Yeah. Think of a sequencer, you have different types of steps in a sequencer. Now, as time goes on, you might want each individual step in your sequencer to have different abilities. In 5 years' time, you might want to add the ability for a step to record to file. In another 5 years' time, you might want a step to be able to have its own user interface, or have its own debug mode, or you might just want to add more and more of this functionality. And so we have different step types: action, pass, fail, and numeric test. Either we get a requirement to have different reporting types, and you think, okay, well, so long as I know up front, I could just use strategy pattern and just use these as different strategies for the test types. And then you get an extra set of requirements for a user interface, and each of those steps should interact with the UI, and ... You might get more and more requirements. With strategy, you would have an object in your class private data of step type, and that object would be of type report or of type user interface. But ultimately, you need to know what these are in order to put those objects in the class private data. Time for a demo. So in here we have different types of step, and so we have, I think, a parent test type. Does anyone remember my last DutLUG talk about the CEF? What's that called? Configuration Editor Framework. Excellent. Got a pair of socks. So with the Configuration Editor Framework, that was a sequencer I developed based on that, and I called it like test and light. That used this design pattern where I had different step types: sequence, pass, fail, action, which just does a thing. And then each of those step types should be able to do things. It should be able to report or have a status interface, or it needs to have added functionality. The way we do that is often called like double dynamic dispatch or double dispatch, where we have our hierarchy of functions and our hierarchy of, in this case, step types. And so we're doing a double dispatch. We're choosing this step type and we're choosing this piece of functionality, and we're squashing them together. Well, that's what we're doing here. If I open up context help, the test, this top object is of test type. And so we're going to get a sequence, a pass, fail, or an action in. Then if we double click in here, we're going to do our second bit of dynamic dispatch. I haven't updated the icon since I implemented this. Instead of visit gold, think visit report generation. And then if we click in here, this is our second level of dynamic dispatch. So if I click here, we get another screen. So report status, reporting could be generating a report here. Status interface could be bringing up a UI and telling the user what kind of status of the step is. Or it could be sending messages to a separate user interface. And the key point to get across here is, provided I've done this right, we shouldn't see each other's hierarchies in the dependencies. So if I open up a new project, and this is a test I do whenever working with actor framework or in like an actor-based architecture to make sure I don't have any cross dependencies. So these steps shouldn't know about the functionality. So if I just control, click, and drag, in dependencies, I expect to see step functions, but not the concrete implementations. No, that's fine. It's just a different types of step there. But we have step functions, but we don't have reporting or status. So in the future, when I need to add extra functionality, I can create a brand new class here, have it implement the interface, and then it will work without bringing it into like the application's dependencies. It could be loaded from a file, for example. Is this making any sort of sense? Okay, I'm getting some nods, some The thing is, in this presentation, I've gone through 5 design patterns, none of them in any particular detail. The point that I really want to make is there's more to object-oriented programming than having like the factory pattern, where you just create an object. There's like, if you're interested in read this book, there are other books like it. This is the one I prefer. is from the gang of 4. This is the gang. There's 4 of them. And it goes through a catalogue of these design patterns. The last thing I want to talk about, actually, is if I open up one of these excepts. Someone tell me what this function is.
Reserve runtime.
Reserve runtime class. How is it different to more specific?
There's an error.
Pardon?
There's an error.
Yeah. All right, if you get an error using one, use the other. Sure. But what is this actually doing? Someone tell me that. It might help if. Sorry, Devon.
I think it's.
No.
Isn't it that it keeps the original class? So it then dispatched to some specific type, and then it keeps the wire the same as the original.
Yeah, you're very close there. So this is called a preserve runtime class. What do we call a class in runtime? An object, yeah. So this function, I think, should be called preserve runtime object, because basically with dynamic dispatch, if this is a dynamic dispatch output, then it needs to be directly linked with the dynamic dispatch input. And if it's not, you're going to get a broken run arrow. What this function is doing is it's reserving the original object. It is turning this object into this object. Whereas to more specific class just makes LabVIEW treat value object like a different class. Whereas this is a different object. To more specific is like a different object.
This one only makes sense in the context of a sub-VIEW, right? If you look at the caller, then the wire actually changes in the IDE, right? Depending on what you've wired in. So if you have your mouse over there, you're going to get the parent type. Whereas on the calling sub-VIEW, you actually get the wire that you put in. That's the important thing. Is this is a development time? It's a development time change, not a runtime thing. That's for me the biggest thing. You see what the wire is going to be depending on what you've got before you even run the code.
That's absolutely right. Reserve runtime class, to more specific class. I think it should be working. Or keep. The thing is, it should just be called reserve object. And I think that would make more sense than reserve runtime class. A runtime class is an object, just delete the extra unnecessary words. And it also makes sense to more people.
It's also in the names of the items you put in
target object, whereas that's target class. Object in. Oh, well, reference, but it's quality one. And also in the description, whether the object in is the same as the target object.
They almost know what they're doing.
So yeah. Right. I am, let's say, 25 minutes over time. So thank you very much. That's everything I have to offer you today. Copy swag, steal swag. I don't want it. Right, thank you very much.